Okay, 6.2b, inverses and determinants with matrix. So we're going to look at some square matrices, 2x2s and 3x3s, and find determinants, get the inverses and things like that. So first, let's talk about the inverse and what it is. But first, before doing that, we got to kind of look at a couple different things. When we think about what's the values of an additive identity and multiplicative identity, so basically what numbers in additive identities, what numbers do we add that make it stay the same? So the additive identity is 0 because anything added to 0 stays the same. Multiplicative identity is 1 because anything times 1 is the anything, right? X times 1 is X. So those are your identities, and that's how we come up with the identity matrix is going to be comprised of zeros and ones. So the identity matrix looks like this. You know, 1, 0, 0, 1. That's your identity matrix. Okay. So why is that important? If we're talking about inverses, then our inverses, to be an inverse, they'd have to make the when multiplied be the identity matrix. So we'll get to that here. But looking at this box down here, if we have an n by n matrix, so it's a square matrix, right? Square. So it's going to have the same number of rows and columns. Then there exists a matrix that basically says that if you multiply them together, they're going to be equal, but they're going to be the inverse or the identity matrix. Okay. If that's the case, then B is called the inverse of A and is written with, oh boy, okay, and is written with A to the negative 1 power, right? The inverse A. Okay. And so we can move on with that. All of that stuff just tells us that when you multiply them by each other, they're going to come up with the identity matrix. Okay, so let's do an example of that. So if it's invertible, meaning it has an inverse, that's what it means to be invertible. The matrix has an inverse. Okay, in a singular matrix, it's a matrix that does not have a matrix. So if we try to find it and it doesn't work out, we will call it singular. Okay. In this case, if the matrix is singular, then if we try to say A times B equals the identity solution or the identity matrix, it will have no solution. So it's a lot of words there to kind of get to what we're getting here. But to determine if two matrices are inverses, basically we need to find both A times B and B times A, and both need to be equal to the identity matrix. Okay, so that's why we kind of went through the identity matrix. So let's try that here on number 1. Determine whether A and B are inverse matrices. So to do that, I'm going to have to multiply A times B. Okay, and I'm going to hope that it gets, and I'm also going to have to do B times A. Okay, and I'm going to hope that when I do that, I end up getting this answer right here for both. If I do, then they have an inverse, and if not, then they don't have an inverse, or they're not inverses of each other. So if we continue with this, A times B, so I'm going in that order, so it'll be negative 3 times 1 plus 2 times 2, doing my matrix multiplication from section 6.2a, and then I'm going to make that a little closer together just so I can save room. So negative 3 times 1 plus 2 times 2. Okay, and then I have negative 3 times negative 2 plus 2 times negative 3. Okay, and in the bottom row is going to look like this: negative 2 times 1 plus 1 times 2. And then over here, negative 2 times negative 2 plus 1 times negative 3. So using our matrix multiplication from the last section, we should be able to do that. Okay, so now let's see what we get here. In the upper left-hand corner, we got negative 3 plus 4 is 1. In the upper right-hand corner, we get 6 plus negative 6, so 0. In the bottom here, we get negative 2. Bottom left, negative 2 times, or negative 2 plus 2 is 0. And then over here on the right-hand side, we get positive 4 plus a negative 4. Or sorry, positive 4 plus a negative 3 is 1. So I have the identity matrix. So that's that for A, B. Do I get the same answer when I go B times A? So let's check it out. When I go B times A, okay, I'm going to just go a little faster through the multiplication here, but I'm just going to skip through it. You're going to do the multiplication ahead. So I'm going to have negative 3 plus 4. Over here, I'm going to have 2 plus a negative 2. So I'm just kind of skipping that step of writing it out. Down here, you'd have negative 6 plus 6 when you multiply. And over here, you're going to have 4 plus a negative 3. Now, you might not be able to do that without doing the extra steps. Just go for it, okay? If you can. Just be careful with your multiplying and additions of positives and negatives. Okay, so negative 3 plus 4 is 1. 2 plus a negative 2 is 0. Negative 6 plus 6 is 0. And then 4 plus negative 3 is 1. So I have the identity matrix here. So I can say that, yes, AB is equal to BA, which is equal to I2, meaning that it's a 2 by 2 matrix, identity matrix, that AB and BA were both the identity matrix. So that's what we would write. Okay, the next section here, how to find the inverse of a square matrix. So I'm essentially what I'm going to do is I'm going to cancel this out for right now because there's a much faster way, and we get to it right after we learn what the determinant is. So there is a way to do this without knowing the determinant, but then we're just going to find the determinant, so we might as well just do that anyway. So we'll come back to these questions here once we find out more about the determinant and what it does with the inverse. So let's keep going and scroll down to the bottom of page 2 where it talks about the determinant. Okay, so this determinant here is a single numerical value. So that's what when they ask for the determinant, you should have a single numerical value as your answer there. And when calculating, and it's used when we calculate the inverse or solving the systems of linear equations. So that's helpful to us to do this. That's why I just, instead of doing the long drawn out process in finding that, which is in the book as well, for those previous examples, why not just use the determinant once we found it? Because it's much faster and easier and just easier to understand. So we go in here and we also denote it as this symbol here, or we can write it as DET with A in parentheses, or we can use the brackets or the absolute value lines technically. But so let's talk about that. So determinant, if we have a 2 by 2 matrix here, A, B, and we're talking about 2 by 2s here. 3 by 3s are a little different. We'll get to those too. But A, B, C, D. Number one, it's invertible if and only if AD minus CB is not equal to 0. So let's make sure we check that first. Okay? If it's equal to 0, then there's no use in trying to find the inverse. So all you're doing is multiplying A times D and then subtracting C times B and getting it there to see if it's invertible, meaning it does have an inverse. If it's equal to 0, it's not going to have an inverse, and you can just write singular and move on. Okay? If it is invertible, meaning if you get any value other than 0, positive or negative, then this is your formula to find the inverse. So you're going to take 1 over the determinant, basically. So you're doing AD minus CB anyways, 1 over that, times a different matrix of D, negative B, negative C, A. Okay? Now, all you're really doing here, if you think about it, is we're just, I mean, it looks like, oh, how am I going to remember that? But all I'm doing is really flip-flopping these two positions, A and D, and I'm just making these negatives, B and C. That's it. B and C stay the same position, they just change signs. A and D stay the same signs, they just swap positions. Okay? That's all you're doing when we do that. So, when we get that number, that AD minus BC, we call that the determinant of the 2 by 2 matrix, and it's denoted like this, okay? So if you've got this, this is kind of how we write it, determinant or either one of those, and then this is your answer how to find it, okay? So now, once we are able to find that, let's go ahead and we'll come back to those practice problems ahead. So let's do these first. Find the determinant of each matrix, then find the matrix, or the inverse of the matrix if it exists. Okay, so the first thing I'm going to do is I'm going to look at AD minus BC. That's really what I'm looking at to see if we have it. So when I do that, I'm going to write, of course, DET of A, which equals this, right? I can use either one of those symbols. I'm just using them both. So AD, this is -5 times -8 is -4, or sorry, it's positive 40. And then 10 times 4 is 40. So 40 minus 40 equals 0. Well, remember, if it does equal 0, then we can just say does not exist. Or we could say singular, meaning it doesn't have a inverse. Okay? All right, how about this one? If we do the same thing here, let's just take it and go, again, looking at AD minus BC in this case. So the determinant, we're asked to find that as well. Okay, in this case, -2 times 6 is -12. And then -4 times 4 is -16. So we have a -12 minus a -16, which equals 4. Okay, so then I can find the matrix by using this equation over here. This thing right here will give us the matrix. Okay, so it's 1 over the determinant. So I can basically say that my inverse now is equal to 1 over my determinant, which is 4. Or I'm just going to write it out the first time here and say that 1 over AD minus BC, which you wouldn't have to do all the time, times these values, right? D, -B, -C, A. Okay. Which then we know equals, let's just switch colors here, 1 over 4, because, right, the determinant was 4. And then we could put those values in. I just swap my A and D's. And then I just change the sign of my B's and C's. So I have that. So now, when I finish for my matrices, I'm just multiplying 1/4 by all of those. So I end up getting 3 over 2 in the upper left-hand corner, right? 6 over 4 simplifies to 3 over 2. -4 divided by 4, or times 1/4, is -1. Then the bottom left, it's going to be +1. And in the bottom right, it's going to be -1/2. And there is my inverse. Okay? So now let's back up, now knowing how to do that, if it exists, to do these problems here. So number 2 and number 3, find the inverse of A if it exists. If it doesn't exist, we can write singular. So let's just first find our determinant. So AD minus BC for this one gives us -4 times -5 is 20. 3 times 6 is 18. So my determinant is 2. So I know it has an inverse. And that inverse is, remember, it's going to be 1 over the determinant, 1 over 2. And again, just writing these D and A over here, -B, -C, okay, is now going to be 1/2 times, again, I just switch these two numbers, so -5 is over here in the upper left, change the sign there, change the sign here, swap that one down here, and now I'm multiplying by 1/2. So this is going to equal -2.5, -3, -1.5, and -2. And there you go. Okay, how about this one here? So again, first thing I'm going to do is I'm going to look at my determinant, AD minus BC. So I've got -12 times -3 is +36, minus 9 times 4, which is 36, which equals 0. So I know right away that it doesn't have an inverse, it is singular. Okay. So the last thing now, if we jump back ahead, is the 3-3 determinant. If we're trying to find the determinant of a 3-3 matrix, a little bit different, okay? A little bit different. So in this case, here is your determinant. If you've got a 3-by-3 matrix, again, so it's square matrices. So now I've got A, B, C, D, E, F, G, H, I in the brackets, right? Then we can define the determinant of this matrix, A, capital A, is going to be these values. So I'm going to take basically my A value and multiply it by EF by the determinant. So remember, these lines mean the determinant. So be careful with that. The determinant of EH and HJ minus B times the determinant of DF and GI plus C times the determinant of DA and GH. Okay, so let's look at see kind of where those numbers come from. Okay, and just got to remember that you subtract, then you add, right? And then we'll find it. It seems like they're random and they're thrown in there, but if we just take a look at what we've got here. So if I look at A is the first one, right? A, I'm kind of just crossing out the ones in the same row and the ones in the same column, and then use the other ones, the determinant of the other ones in the rows that are not in the column A. Okay, E, F, and H, I, right? So if I keep going with that, same thing with B. Okay, if I look at B is the next one. Okay, if I look at B, again, all I'm really doing is I'm going to cancel out the ones in the same column, and then I'm doing the determinant of what's left. DFGI, okay, as you can see right there. Right, and same thing, if I look at C, C is right here, and then I'm just going to kind of cross those out, and I'm going to do the determinant of DE and GH right here. So that's how we get these numbers. Okay, so as long as you just plug them in the right order and pay attention to what you're doing there, you should be fine, because then it's just multiplication and subtraction. So let's take a look at this one. So again, we know that our determinant here, we're finding the determinant of A, which we can also write like this, right? These long lines mean determinant. Okay, so I'm just going to plug in the formula here. Again, it's going to be the A value times the determinant of EF, EF, H, and I. Just kind of throwing that out there. And then you don't have to do this if you get the system down. That's a way to skip. EF, GI plus C times DE, GH. Which I'm just getting that from right above here. Okay? And I told you, we showed you how to do that. All right, so continuing on here. So the A value here is 3, so it's going to be 3 times the determinant of EF and HI, which are the bottom right-hand corner, basically, -1, 4, 2, 5. Then I'm going to subtract B. Well, B is this one. So we're using 1 times, and be careful not to make brackets because people think matrices then. -2, 4, 1, 5 would be the values we're finding the determinant there. And then plus 0, because that's the C value. And then we're going with DE and GH, which then would be -2, -1, 1, and 2. Okay, so now I've got to find the determinant of all these, and then kind of add and subtract and add. So let's do that. Over here, now I'm going to have 3 times whatever the determinant is here. Well, this determinant, remember, is going to be -1 times 5 minus 4 times 2. Right, because we're doing this, subtract that. Okay. Then, and again, you could do more of this faster. Just be careful with your -1 with your numbers that positive and negatives. But in this case, now it's going to be -1 times -2 times 5. Subtract 1 times 4. And then we're going to add 0. Now I know I'm just going to do the math here because you know that anything times 0 is going to be 0, but it'd be 0 times -2 times 2 minus 1 times -1. Okay, which we know is going to be 0 anyways. I just wrote it in. All right, so now continuing here, we go with 3 times what's in the parentheses. Well, I've got a -5 minus 8 is a -13. Then I've got a -1 times what's in the parentheses. That's going to be -10 minus 4 is -14. And then we know over here it's going to be plus 0 because anything times 0 is 0. So now I've got -39 plus 14, negative times a negative, which then equals -25. Then that would be the value of my determinant. Okay, the determinants and inverses all right there for you. Hopefully it went all right. Any questions, we'll work on it and we'll be good to go. Have a great day.